Welcome children, welcome back to Refresh Concepts with me Dinesh Modi. Let's proceed further with a new chapter, and as the title mentions, it's similarity. Now children, in similarity we deal with certain properties, theorems, and based on the properties and theorems is what we have sums. So if you want to master similarity, you should master first of all the properties and theorems which are there, and then just apply the same properties and theorems into the sums. That's what the sums are all about. To start off with the first one, though the chapter name is similarity, we won't directly start into the similarity part. So what we shall do is we shall come across some of the main properties, main theorems, and then we come across the actual similarity part. So start off with the first one is properties of ratios of areas of two triangle. What is it? Properties of ratios of areas of two triangle. Now if you can see that I have written something, will be explained to you in detail. Right? Just focus on this one. Properties of ratios of areas of two triangle. So what is the title trying to say, children? The title says that we shall be having areas of two triangle. Moreover, we shall be having ratio of areas of two triangle. We shall be having ratio of areas of two triangle. And I have given something called as 1A, 1B, 1C and 1D. Everything will be told to you. So to start off with, let's start in. Properties on ratios of areas of two triangle. So say, consider it has been given to me, there is one triangle ABC. There is one triangle ABC and there is one more triangle PQR. There is one more triangle PQR. This is nothing but height AM of triangle ABC and this is nothing but height PN of triangle PQR. So what is given to us, children? We are being given two set of triangle. One is ABC with base BC and height AM, altitude AM you can say so. Other is PQR with base QR and altitude or height PN. So what if I have to say first area of triangle ABC, children. If I have to say what is area of triangle ABC, immediately you shall say that area of triangle is nothing but half into base into height. So rightly said, area of triangle is half into base into height. I shall say half into base into height. Base is my BC and height is my AM. I am talking about area of triangle ABC. I am talking about area of triangle ABC. So area of triangle ABC is nothing but half into base into height. Likewise, if I have to say what is area of triangle PQR. So area of triangle PQR is nothing but half into base, which is QR, into height, which is PN. Right? As we did for the first one, area is half into base into height for the first one. Likewise goes for the second one. Now I say I want ratio of areas of two triangle. When I say I want ratios of areas of two triangle, don't you think so that I need to have a numerator and denominator? So let me say divide expression 1 by 2. So if this is my first equation, this is my second equation, let me divide that. What will I get? Area of triangle ABC upon area of triangle PQR, LHS. What I'll get in the RHS? Half into BC into AM, half into QR into PN. Don't you think so, children? Half gets cancels off. Half gets cancels off. What I'm left with? BC into AM upon QR into PN. So let me write down once again, what is it? Area of triangle ABC upon area of triangle PQR, area of triangle PQR is nothing but BC into AM upon QR into PN. Now children, focus. What is BC? BC is nothing but base of the first one. What is AM? Height or altitude of the first one. What is QR? Base of the second one. And what is PN? Height of the second one. So what can I conclude now? The very first property 1, which I have bifurcated. So let me say this is property 1. Property 1, I have bifurcated into 4 parts, 1A, 1B, 1C, 1D. So what is the first property 1A trying to say? the ratio of areas of two triangles, mind you. Here we are not talking about anything about similarity. We are not talking anything about similarity. The ratio of areas of two triangles is equal to, again the ratio of the product of their corresponding bases. BC and QR are the corresponding bases and their corresponding heights AM and PN. So henceforth in similarity only, mind you, in similarity only, or whenever you talk about the ratios of triangles, whenever you talk about the ratios of areas of triangles, mind you, we shall never take half into account. Half got cancelled. So we have the first property in our hands, 1a. The ratio of areas of two triangles is equal to the ratio of the product of their corresponding bases and heights. The ratio of the areas of two triangles is equal to, once again, the ratio of the product of their corresponding bases and heights. Are you getting me, children? Right? So this is our property 1a. This is our property 1a. What is property 1a and what it talks about? It talks about the ratio of areas of two triangles. What it says? The ratio of areas of two triangles is equals to the ratio of the product of their corresponding bases and heights. Ratio of the areas of two triangles is equals to the ratio of the product of their corresponding bases and heights. We shall never include now half in each of the case. Half gets deducted. Right, children? What is 1b? Right? 1b. B. So I'm emphasizing logical part, nothing to do with concepts, logical. B. So what will I do is, I shall give you one simple diagram. One, A, B, C and D. Now I just want two hardcore main triangles. There are many multiple triangles, but if I have to say just go via letter and give me two triangles, the triangles are going to be ABC and triangle is going to be BCD. I know that even this is a triangle, this is a triangle, this is a triangle. I don't want that. I want from the triangles which I have given, the naming which I have given. Right? 1B. So focus, I have a relation to say so logically. What type of triangle ABC and BCD are? What type of triangle ABC and BCD are? They are obtuse angle triangle. They are obtuse angle triangle. You can just see ABC is also obtuse with angle B obtuse. BCD is also obtuse with angle C obtuse. And we know our basic says, quite lower classes basic says, height of an obtuse angle triangle is always outside the triangle. Height of an obtuse angle triangle is always outside the I need to have height of this one. So let me just write on B over here. B is here. So height of triangle ABC is somewhere outside. You can extend this and say this is AM, altitude. And height of triangle BCD is again outside. And this is nothing but DN, altitude. So I have two triangles, ABC, another is BCD. Both being obtuse, heights are outside. For ABC, height is AM. For BCD, height is DN. Now I want to talk about ratio. Now since we have learnt property 1a, so we will not talk about half. What I will say directly, the ratio of areas of two triangles is equals to product of their corresponding bases and heights. So let me directly, now when we know that we are going to talk about ratio, so shall I say area of triangle BCD, ABC first. First we'll take ABC. So area of triangle ABC upon area of triangle BCD Since we have learned property 1a, what direct answer will I have? It is equal to the product of their bases and heights, corresponding bases and heights. What is the base of ABC? BC. What is the base of BCD? BC. They have a common base. Now you remember what did I said a couple of minutes back? 1B, B, B. B means base common. B, base common. First of all, if we go with our property 1a, answer shall be base into height, AM. Base into height, DN. But sir, base is common. So we can easily cancel BC. What I'm left with? I'm left with AM by DN. I'm left with AM by DN. So the ratios of areas of two triangles, with same base, don't you think so? We have same base BC. Indeed, we have same base with same base is equal to the ratio of the corresponding heights. What is AM? Height of the first triangle. What is DN? Height of the second triangle. So one more parameter got deleted. In the first one, what got deleted? Half. In the second one, what got deleted? Common base. So base got deleted. So the ratio of the areas of two triangles with equal base or common base is equal to the ratio of the corresponding heights. The ratio of the areas of two triangles with common base or equal base is equal to the ratio of the corresponding heights, mind you. So if you want, what you will write down, direct answer will be area of triangle ABC upon area of triangle BCD is equals to AM by DN. When you apply all these things directly, you have to mention those reasons which I have written with red ink. Here also, these are the reasons which you have to by hearted, children. These are the reasons. So wherever you apply these, you have to mention these as reasons. So you should be very well versed with it. Right? So if not, try to by heart it with me. Right, children? Now with 1A done, 1B done. What was there in 1A? Nothing common. What was there in 1B? B, base common. Now what is 1C? C. So there are many who will be, might be. They are saying side common, but we have nothing of that type. So let's see what is C going to be. Let me draw two parallel lines. This is line L and this is line M. This is line L and this is line M. Now I have two triangles. One is A, B, C. And I have P, Q, R. I have ABC and I have PQR. Now what is it? They have, right now you can say those are two disjoint triangles. Mind you, ABC is totally different, PQR is totally different. But both of them are embedded between the two parallel lines L and M. I have already said that L and M are nothing but my parallel lines. Given from our side. So if I were to write down answer right now, what is area of triangle ABC? Area of triangle ABC is nothing but, once again, ABC is an obtuse angle, so height is going to be somewhere outside. So this time let me say height is H1. Height is H. Base is BC, height is H. Now just tell me, what is area of triangle ABC, height of area of triangle ABC? Or rather height of ABC, it's going to be H. What is height of PQR? Again it's going to be H. So why this time H? Because they lie between two parallel lines. Their height are going to be same. So what is area of ABC? Area of ABC, if I go in context to 1A, it should be base into height. Base is BC, height is H. Base is BC, height is H. Likewise, if I go with area of triangle PQR, again base is RQ, height is H. Since they lie between two parallel lines, their heights are equal. This is what we got it via property 1A, corresponding bases and heights. But now when we know that the heights are equal, what I'm left with? I'm left with BC by QR or RQ. Thus, the ratio of the triangles with common or equal height, since they lie between two parallel lines, they have equal height. Now I'll make you understand what is common height. I'll make you understand that also. Is equal to the ratio of their corresponding bases. What is BC and QR? Corresponding bases. So this is property 1C. Once again, what is property 1C? Property 1C is that if there are two triangles with equal or common height, the ratio of the areas of those two triangles with equal or common height is equal to the ratio of their corresponding bases. Right, children? Now, For 1C, where we have a case where the heights are equal, so how the figure is going to look like? The figure will be either the two triangles will be placed between two parallel lines. The two triangles will be placed between two parallel lines, or at times parallel lines is not given to us. Then what is given to us? Let me tell you that also. You will be given, say, I'm giving a totally different example. You will be given something of this nature. I'm giving you a totally different example. This is A, B, C, and this is D. Mind you, we are not connected with this. We are not connected with this now. How many triangles can you see, children? According to me, there are 3 triangles. One is A, B, C, complete one, A, B, C, the bigger one. The other is A, B, D, and the last one is C, D, A. The last one is C, D. I see 3 triangles. I'll pick up any 2 because I want to find out the ratio of any 2, mind you. So, say if I pick up the first and the second one, when I say first and the second one, what do I mean by saying is A, B, C and A, B, D. Children, here is the answer when I say they have common height. When can I say they have common height? When can I say they have common height? Listen to me carefully. Triangle ABC and triangle ABD have a common vertex A. Have a common vertex A, and their base BC and BD. BC for the first triangle, BD for the second triangle lie on the same line. Therefore, their heights are equal. Therefore, their heights are equal. How can we claim triangles with equal heights if they are not embedded within 2 parallel lines? We can claim in this way. So what they need to have for we to claim them as equal heights, they need to have a common vertex. They need to have a common vertex, and their bases should lie on the same line. Once again, triangle ABC and triangle ABD have a common vertex A, and their base BC and BD lie on the same line. Therefore, their heights are equal. Sir, how about triangle ABC and ADC? Once again, ABC and ADC have a common vertex A, and their base BC and CD lie on the same line. Therefore, their heights are equal. And lastly, triangle ADB and triangle ADC again have a common vertex A, and their base DB and CD lie on the same line. Therefore, their heights are equal. Therefore, their heights are equal. So out of the 3 cases, let me pick up any one only to make you understand. Let me pick up any one to make you understand and write down by different marker. So this is different, which we have already learned. This and this goes parallel. Only thing is diagram is different. Mind you, diagram is slightly different. Diagram is slightly different. So what if I have to say area of triangle ABD and area of triangle ADC? Area of triangle ABD upon area of triangle ADC is again what? BD by CD. But prior to that, you have to write down. You have to write down this as a reason. What is the reason, sir? Triangle ADB and triangle ADC have a common vertex A, and their bases BD and CD lie on the same line. Therefore, their heights are equal. Since their heights are equal, with this particular statement, the ratio of the triangles with common or equal height is equal to the ratio of the corresponding bases. Right, children? So property 1A. So property 1 in general talks about ratios of areas of triangle. Property 1 in general talks about ratios of areas of triangle. Property 1A, where there is nothing common. So answer is product of the corresponding bases and height, half being eliminated. Property 1B, B, common base. Ratio of areas of 2 triangles is equals to the ratio of the corresponding heights. 1C, common height or equal height. Ratios of areas of 2 triangles is equal to the ratio of the corresponding bases. We showed you 2 ways how to find out equal height. So what according to you 1D should be? We are done with common base. We are done with equal heights, common heights, equal heights. What according to you 1D should be? Rightly pointed out. Common base also and equal height also. That means base and heights are equal. So how the figure will look like? How the figure will look like? Say this is line L. This is line M. And I have 2 triangles A, B, C, D. So one is triangle ABC, other is triangle BCD. Are both the triangles lie between 2 parallel lines L and M? Indeed. It's been given to me that L and M are parallel lines. Since they lie between 2 parallel lines, their heights are equal? Yes. ABC and BCD have a common base BC. They have a common base also. So let me first jot down. S per property 1, because every property is what we have derived from property 1A. Right? And then we kept on cancelling the things which are common. So let's write down, what is area of triangle? Area of triangle ABC. Area of triangle ABC is nothing but base BC into, let me say, height H. Here also it's going to be the same, H. Base BC into H. What is area of triangle BCD? Is again BC into H. When I say ratio, we divide it. BC gets cancels off, HH gets cancels off. Ultimately what we are left with, 1 by 1. So what you have to do is, you just cross multiply BCD over there. Cross multiply. What I'm left with, area of triangle ABC is equals to area of triangle BCD. Area of triangle ABC is equals to area of triangle BCD. Triangles with common base and equal height are equal in areas. Triangles with common base and equal height are equal in their areas. Right? 1D. So what is the summary of this property? Very first thing, this is property 1. This is property 1 of similarity. And what is property 1 talks about? It talks about ratio of areas of triangles. We haven't started similarity. Ratio of areas of two triangles. Right? Property 1A, ratio of areas of two triangles is equals to the ratio of the product of their corresponding bases and heights. Property 1B, B, common base. Ratio of areas of two triangles with common or equal base is equal to the ratio of their corresponding heights. 1C, the ratio of the areas of two triangles with equal or common heights is equal to the ratio of their corresponding bases. Finally 1D, where the heights and bases are equal, their areas are also equal. Thus, triangles with equal base and common height have their areas equal. 1D. Mind you children, all these four properties is what you need to be very well versed with. You should know. Why? Because you have to write down that as a reasoning type. Besides the sum, wherever that is applied, you have to write down that as a reason, right? And this is very, very important to initialize our similarity.